Intro to Civil Engineering. First, one of the questions for this lecture is, how do I read a building plan? How to read a building plan is related to civil engineering, so we know how to construct buildings, lay them out, also do structural and read architectural plans. So all of that is encompassed in civil engineering. The question is, what's civil/structural engineering? We can frame this as a story about Anna. So Anna is a civil and environmental engineer who's thinking about going through school and wants to know what the different fields are in civil engineering. Her question is, what can I do? So there's construction, geotechnical, structural, transportation, water resources, and environmental. Those are some of the main fields of civil engineering. There's also applications in the entertainment industry, so civil engineers could build structures that apply to aerospace, Hollywood, theater and set design, things like that. This building is also one of my favorites. It's a ski slope on top of existing plant in Copenhagen, made by BIG, the Bjarke Ingels Group, an architect. So there's a lot of collaboration between environmental, architectural, and structural. To understand civil engineering, we can have a definition by the ASCE, American Society of Civil Engineers. Civil engineers design, build, and maintain the foundation for our modern society: our buildings, roads and bridges, drinking water and energy systems, seaports and airports, and the infrastructure for a cleaner environment, to name just a few. With Anna, she wants to know some places where she could work if she got a bachelor's degree. So some places using those topics: transportation engineering, she could work at Caltrans; geotechnical engineering, she could work for the city of San Francisco; for construction, she can be a project manager at Level 10, which is a construction general contracting company. She could be an environmental engineer at a water district, such as the Santa Clara Valley Water District. She could be a project or civil engineer with government, at the local or federal level. She could be a structural engineer at a small or large structural firm, working on buildings or bridges. She could even be a city or a building inspector, such as a plan reviewer at a company such as CSG Consultants, or for a city. And on the right side here is a picture of one of the structures built at NASA. So this is a 380-foot tall structure. You can treat this as a movable skyscraper. If you Google some civil engineering jobs and look at them, you can find some such as on Indeed or Glassdoor, and you can see some examples and the salaries. This part I leave as a demo for you to try out. Also, there's relevant topics, so when California has earthquakes or a drought, for example, she knows that civil engineers play a role in it. For water/environmental, there's this place called the Advanced Water Purification Center. It's created in Santa Clara from the Santa Clara Valley Water District. So this center purifies water. They take wastewater, such as from toilets or sinks or anything that goes down into our sewer systems, and it filters it and makes it back into potable water, which is water that you can drink or use for irrigation purposes. A lot of them are for irrigation on farms or landscaping, and they're usually indicated with purple pipe or purple manhole covers, which you might see. This place is also open for field trips, so you can sign up to take a field trip and view this center. Here are some of the different microfiltration techniques, or at the end there's a reverse osmosis. Another example of civil is transportation. So you can pretty much work on roads and bike lanes and mass transit, such as BART. So you can work for BART and major transit agencies such as SFMTA, San Francisco Municipal Transportation Agency. You're part of larger planning and these special districts which govern how trains and transit goes through multiple cities or even within one city. From here you can see that there's the region that encompasses the Bay Area, and we're governed by different transportation agencies. To compare the density of the Bay Area to different transportation structures around the world, this is the transit map for Tokyo, the Tokyo subway route map, and the density of Tokyo is much more than the Bay Area. This region shown on this map is actually a very small portion of the Bay Area if you were to compare the square footage. For example, this is 847 square miles versus the Bay Area, which was about 6,966 square miles for these 9 counties. as an image, this is the density of Tokyo. So civil engineering encompasses urban planning, transit, the development of our cities. A good way to summarize this is it is everything that is built above ground and below ground. Anna also recognizes that our transportation is outdated. For example, around the world, there are different uses of bike lanes, pedestrian walkways. So under transportation engineering, a civil engineer would redesign streets or design new bike paths to reduce collisions with bikes or pedestrians. One example is at the city of San Francisco, they work with this agency called NACTO. NACTO provides guidelines for how to design streets and bikes, bike lanes, and mass transit all around the world, and the city of San Francisco is a part of that organization. One example here is how can you design bikes to safely turn at an intersection, and intersections have a high rate of collisions between cars, but also bicyclists and pedestrians. So one way is to look at some of the guidelines provided by NACTO and some of the transportation code. And there's measures that are used like protected cycle tracks or bike boxes, widening the sidewalks, reducing the lane widths of cars. So as an exercise or as a project, you're also able to build your own kind of cityscape and understand how to design your own bike lanes using AutoCAD for an introduction to engineering course or as a traffic engineer. Here's an example of what it looks like when we have transportation thought out by engineers and planners. The question is there a system that actually improves public transit, such as the measures of ridership and speed and pedestrian and bike safety, and it also helps with pollution? A system that is an alternate to heavy expensive rail, like trains, a system that uses vehicles we already have, and it can be replicated using techniques that are 1/10 of the cost. So this is bus rapid transit. This is an example in Van Ness in San Francisco. This video would show some interviews with people who enjoy this route. So instead of creating a BART or heavy mass transit through the middle of the street, they can replicate it using buses. So this would be bus rapid transit. And you can mimic the flow and the volume of people carried through BART, but using buses. So there was good feedback on BRT throughout this main corridor in San Francisco. Another question, what about inspection, construction management, project management, and structural engineering in general? This is the Costco on Hesperian and Hayward, and they created a new gas station structure. So on the left side you see the inside, you can see the steel framing, and then on the right side is completed. So transportation engineering, construction, and structural engineering is part of civil. You can also see these hands-on in student competitions. So if you join ASCE student competitions, you can mimic some concepts used in industry. The first one on the top is geotechnical challenges. So you can make a box of sand that is held together on one side using paper. So you use geotechnical engineering techniques, which you learn about the property of soil and sand, and you're mimicking a retaining wall. And in this picture at the top of the car, there's a wall that is being retained, like the soil is being held back, and you can see these like anchor looking things into the wall. And on the bottom left is a picture of that kind of retaining wall, but using paper and strips of paper. On the bottom right is a picture of concrete canoe. So schools also race canoes made of concrete, and you can learn about principles of structural engineering in the concrete mix design, the hydrodynamics of making a concrete canoe float, and even the construction management of making a canoe. There's also surveying. So there's the idea that engineers are involved with measuring the land, plotting out the land. You can also become a surveyor, which is not necessarily requiring a civil engineering degree, but engineers would take on this class in a typical undergraduate setting and learn how to do surveying. So surveyors would know how to use tools like total station instruments. They would make reliable estimates. They would understand how to record data on parcel maps, measuring out property lines. Here's an example of a TikTok that became popular where someone threw a party at a house and the floor actually collapsed. So on the left side is the TikTok, and on the right side is the police body cam footage going through the underneath of the house. And you can see underneath the house the type of structural systems and actually how this floor might have failed. And it looks like it failed from a shear failure where the floor fell down from the sides. You can see that the floor is intact, but you can see that the support of the floor at the ends is what failed, and the floor kind of caved in because of that. So structural engineering is designing structural systems, elements, and connections by knowing their physical properties and physical laws to predict behavior. So you can design based on how a building will fail. If you know how the structure will fail, or anything in general, if you know how it will fail, you can design against it. Some considerations for this are following the chain reaction and load path. Load path is tracking the path of the load from the beginning to end, so you can see the reaction from point A to point B, see how it will fail, and think about how the elements will attach together and how the elements themselves will perform. These pictures are showing failure from an earthquake, so structural engineers will think about how the elements can attach to each other, how strong each element is, and how complex the structure will perform as a whole. So globally, how will the building perform, and locally, at each connection point and at each element, such as a beam or column, how will those perform? And then you can optimize it for criteria. A lot of these will require statics and structural mechanics, which are courses that relate to physics and the properties of the item. So the stresses in that item, analyzing failure. You can use this for popsicle stick bridges. So there could be an experiment. These are some pictures with students where they make a popsicle stick bridge and they see the failure based on how it's loaded. So the bridges are loaded to failure, and you can see some of the failure points, which could be at the joint of each bridge in this truss system. And on the right side, you can see that the popsicle stick itself bent and cracked here to failure because of the way that it was supported and the way that the load was applied. So generally in a truss system where there's a lot of triangles, you'd want the failure to be at a joint and not really a single element such as this. So there's different ways to design for the popsicle stick bridges. And when you create your own, you can use structural engineering techniques.